Hello, everyone. Welcome to Miss Lockhart's algebra class. I had my intro music going. It was She's a Bad Mama Jamma. It's like an old song. But my brother decided to come in here and take my phone. And I started the recording, so I can't like go run after him. So no music. So sad. But I hope y'all are doing well. I miss all of you. It's been great to see some of you during office hours. Please come by and visit office hours. You know what? Visit all of your teachers' office hours. We're so bored. We don't know what to do without you all. We need to see you all. So please come to office hours. I have them every day from, let's see if I can write it down, from 10 to 11 a.m. And the link will be in haiku. Okay. Hey, come hang out. Come say hello. All right. So I have a couple of announcements and some reminders. Then we'll go over your bell work. We'll do some guided notes. And then the skill check and IP will be for you to do at the end. Make sure that you watch all of the video in order to get some good practice. It will really help you when it comes to completing the skill check and the IP. If you have any missing work, please take a picture of it. So don't submit it through anything on the Google form or haiku. If you have any missing work, it can be submitted through email. Okay, so take a picture of the front and back, email me the pictures. I'll grade it by the end of the week and get that into the grade book for you. Some of you have already done this, so awesome job. I can think of LJ, Selena, and someone else. Ruchapa. Yeah, you all have already done that, so that was a great thing to do. The rest of you, please follow suit if you have any missing work or any work that you just want to turn in to me. Okay, and remember, please attend office hours, mostly because I miss you all, and also to get help on your math. Okay, all right. Let's make sure you complete the bell work. Okay, so you can pause the video and go back to the haiku page, click on the bell work link, and try that, and then come back and we will move forward. Okay, some hints on the bell work. When it asks for the A times C value, you'll have to first find your A, B, and C. And then when it says A times C value, they actually want you to multiply the values of A times C once you find those. Okay. And then in this time in the bell work, there was no space for the magic numbers. You'll just have to write those down on your scratch paper. And then the factors at the end, what that is asking you for is that's asking you for your 2 sets of parentheses with the information inside. Okay. A lot of you last class, you all were putting plus signs in between your final answer. There should be no plus sign in between your final answer. It should just be 2 sets of parentheses right next to each other. Okay. All right. So we do not have a bell work review today. If you have questions on the factoring problems on the bell work or the factoring by grouping, please come to my office hours or send me an email. If you want to have office hours outside of 10 to 11, just email me and then I'll hop back on the link, okay? All right, let's get started with probability. So probability tells us the likelihood of a random event happening. Oops, let's go back. I wanted to fix this typo here. A random event happening, okay? So probability is always expressed in a ratio or a fraction, okay? And this is a great equation that we can use to calculate the probability of just about anything, okay? So in the numerator is where the favorable outcomes go. And it's the event you are seeking to happen, and then the possible outcomes are the total number of things that can take place. So first example, what is the probability that you will roll a 6 on a 6-sided die? Okay, so what goes on in the numerator is the number of times you can find a 6 on the die. And then what goes in the denominator is the total amount of numbers on a die. So we would have, on a dice, there's only one 6. So the probability that we see a 6 would be once. And then there are 6 numbers total on the dice. So that will be our fraction. Okay, so there's a 1/6 chance that you will roll a 6 on a 6-sided die. I know you don't have whiteboards, so this would be most likely, or if you do, on your whiteboard, on your tablet, on your scratch paper, on the back of a random piece of paper that you found in the drawer. Let's do this practice problem. Okay, so what is the probability of rolling a 2 on a 12-sided die? So what we do first is we have to figure out the probability of rolling a 2 on a 2-sided die. We'd put 2 in the numerator, the total on the denominator, and we can simplify the top and bottom by dividing by 2. And we'd get 1/6 as the probability of rolling a 2 on a 12-sided die. Let's try this one. What is the probability of rolling an even number on a 6-sided die? Okay, so we had to figure out all the even numbers that are possible on a dice. So we have the number 2, we have the number 4, and we have the number 6. Those are the only even numbers on a 6-sided die. Okay, so we have to count the number of options that we could possibly come up with. So we have here a total of 3 options. So in our fraction, we'll have 3 on top because there are 3 even numbers to choose from over a total of 6. Okay, so here's our probability, but if we can reduce it, we always want to. So we're going to divide the top and the bottom by 3, and we'll get 1/2 as our probability. Okay. Here's our second example. What is the probability of flipping a coin and getting tails? There is 1 tail on a 2-sided quarter. Therefore, the number of favorable outcomes equals 1. There are 2 sides on a coin. Therefore, there are 2 possible outcomes. So our fraction would be 1 because there's 1 tail on a quarter, divided by 2 because there's 2 options, heads and tails. I don't know what I'm drawing right here. It's supposed to be an arrow, y'all. So the total probability is 1/2. Okay. Example 3. What is the probability that you will draw a king from a standard deck of playing cards? Okay. So we have to think to ourselves, how many different king cards are in a stack of cards? Well, I play lots of spades with my family, so I'm familiar with the number of kings in a card deck. Okay, if you're not familiar with that, I'm going to tell you now. There are 4 kings in a deck of cards. Okay, so there are 4 possibilities that we could choose a king. So that number 4 is going to go in our numerator. Sorry, I don't mean to keep changing the screen. So 4 goes in our numerator, and there are 52 cards, so that number goes in our denominator. Okay, we can simplify 4 divided by 52, which we always want to do if we divide the top by 4 and our denominator by 4. Okay, 4 divided by 4 gives us 1, and 52 divided by 4 gives us 13. So the probability would be 1/13 because we simplified our fraction 4/52. Okay. Let's practice. What is the probability of drawing a heart from a standard deck of cards? Okay, so we have to think about the number of hearts cards inside of a card deck. Okay, we have the ace of hearts, the king, the queen, the jack, the 10, the 9, the 8, the 7 of hearts, the 6 of hearts, the 5, the 4, the 3, and the 2. So there are 13 hearts cards in a deck. So we know our numerator would be the number of hearts cards in a deck, and that is 13. Divided by the number of cards total, which is 52. So we have 13 divided by 52 as our probability. The next thing we need to do is simplify our fraction. So is there a number that I can divide 13 and 52 by? Yes. Let's see. So I can divide 13 by 13. And it also turns out that I can divide 52 by 13. So my fraction, my new reduced fraction, is 1 over 4. So the probability would be 1 over 4. So that means every time I pick up 4 cards, there's a chance that one of them will be hearts. Example 4. You have a bag of marbles that contains 3 yellow marbles, 4 red marbles, 7 blue marbles, and 6 green marbles. What is the probability that you will pull a red marble from the bag? Okay. Now, the number of red marbles in the bag, which is 4, is the number of favorable outcomes. Okay, so there are 4 red marbles. That's what we're going to put in our numerator. However, the problem didn't give us a total. They just gave us 4 red marbles, 3 yellow marbles, 7 blue marbles, and 6 green marbles. So if I need to know the total number of marbles, I need to add 3 plus 4 plus 7 plus 6, and that will give me 20. Okay, so that total number will go in the denominator. So our probability fraction would be the number of reds in the numerator and the number of total marbles in the denominator. Okay, of course we need to reduce our fraction, so we're going to divide the numerator by 4 and the denominator by 4. 4 divided by 4 gives us our new numerator of 1, and 20 divided by 4 gives us our new numerator of 5. So when they don't give you a total, you want to make sure you add up all of the values that they do give you. Okay, so it says you have a bag of marbles that contain 5 yellow marbles, 1 red marbles, 6 blue marbles, and 4 green marbles. What is the probability you will pull a blue marble from the bag? So the blue marble number is 6, and that's going to go on top. Now, we do not know our total, so we have to come up with our total. So we'll have 1 plus 6 plus 4 plus 5, and this will total to 16. So our total is 16. Now we have to think, is there a number I can divide 6 and 16 by? And it would be yes. We can divide both of these values by 2. So 6 divided by 2 is 3, and 16 divided by 2 is 8. So our new probability is 3 over 8. Here's another one. How about you try this one on your own first? Okay. So you have 7 bags of marbles that contain you have a bag of marbles that contain 3 yellow marbles, 7 red marbles, 6 blue marbles, and 5 green marbles. What is the probability that you will pull a yellow marble from the bag? So we find the number of yellow marbles, which is 3. and we put the total in the denominator. They didn't give us a total, so let's add all of our values together. 3 plus 7 plus 6 plus 5. That would give us a total of 21. Hee hee hee. Sorry, y'all, my phone keeps going off. So our total would be 21, so that goes in our denominator. And the last thing we do is reduce the fraction. So we divide the top and bottom by 3, and we'll get 1 divided by 7. Okay. Example 5. You are playing a game with a spinner. You need to spin white in order to win the game. What is the probability your spin will land on a white? So we know we have 2 white spaces, so that's our favorable outcomes. And the total number of spaces we would actually need to count ourselves. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 spaces, so that's our total possible outcomes. So we put our number of white spaces on the top and the total on the bottom. We reduce our fraction, divide top and bottom by 2, and we'll get 1 over 6 as our final probability. Okay. So let's try this on our own. What is the probability of the spinner landing on a 6 space on the spinner below? Remember, you can pause this and try it on your own if you want to before I give you the answer. So a 6 space. So let's figure out how many 6 spaces there are on the spinner. Well, if I go around, I see 1, 2, 3, 4, 5. Here's a 6, 7, 8, 9, 10, and that's it. So there's only 1 6 space on the spinner. And then the total numbers on the wheel will go on the bottom, which is 10. So our probability of spinning a 6 is 1 out of 10. So that means if I spin it 10 times, most likely one of those times I'll land on a 6. So there are several different types of probability. Up to this point, we have only talked about simple probability, dealing with one item and one outcome. But of course, there are other types of probability, and we'll learn about those later. Actually, next class. But I'll give you a preview right now. So joint probability calculates the likelihood of 2 events occurring together. And we usually represent those in what's called a frequency table. So to calculate the chance of these events occurring together, you multiply the probability of the first event occurring with the probability of the second event occurring. But don't you worry, we won't start with frequency tables today. We will wait until next class and we'll learn all about that then. Example 6. You are playing a game with a spinner. If you spin a red or yellow, you will lose the game. What is the probability that you will spin a red or a yellow? Again, we have to go through and count the number of yellow and red spaces combined. So there are 1, 2, 3, 4. So that number 4 will go in the numerator. And there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 spaces total. So that goes in the denominator. We reduce our fraction down to 1/3 by dividing our numerator and denominator by 4. So try this one on your own. Go ahead and pause it and come back for the answer. So what is the probability of the spinner landing on a red or 5 space? So we have 1 5 space, and then we have 1 red space. So that's 2 chances. divided by the total number of 10. And we can reduce this fraction by dividing the top and the bottom by 2. And we'll get 1/5 as our probability. What is the probability of the spinner landing on an even number space on the spinner below? So let's go ahead and circle all our even numbers. 2, 4, 6, 8, 10. So there's 5 even numbers out of the 10 total numbers. This reduces to 1/2. Divide the top and the bottom by 5. All right, we will go ahead, in the interest of time, we are going to go ahead and not do example 7 or whiteboard practice number 7. All right, we are done for today. If you need any help with any of this, please email me or I'll see you at office hours. You can click that office hour link from 10 to 11 a.m. If it's after that, please email me and I will get on the link and we can have another office hour at that time. Okay, so what I need you to do is stop the video, go to your skill check, and then complete your IP, and then you'll be done for today. Have a great day.